Hi everyone, in this video we are going to solve Leetcode 33 search in rotated sorted array. So the problem states there is an integer array nums sorted in ascending order with distinct values. So prior to being passed to your function, nums is possibly rotated at an unknown pivot index. So that means we are given an array of numbers which is rotated at a particular index. So let's say this is our pivot, so the array will be rotated just like this: 2 3 4 5 and 0 1. This is how our array will be rotated and passed to our function, and we need to find whether the given target exists in this array, right? So this problem can be easily solved by traversing the array and finding whether the value exists or not, but that would take O of n time complexity. So in the question they have given, we have to solve it in O of log n time complexity, which is lesser than n, right? So how to solve this problem? If you want to solve it in O of log n, so there is only one possibility, that is using binary search, right? But in order to use binary search, our array has to be sorted, right? The given array is sorted, but it is rotated, right? That means one part of the array will always be sorted. Makes sense, right? So let's say we take this example itself. Here this is an rotated array, but if you check here, this part of the array is always sorted, right? This is always sorted. That means with this observation we can find, if an array is rotated, one part of the array will always be sorted and the other part of the array will always be sorted. We will be having two arrays which are sorted, right? This part is sorted and this part is sorted, right? So with this observation we can use binary search to find out whether the target exists or not. How? The same way we use binary search. We find the mid first, then what we do, we check whether the mid and the low, if low is if low is lesser than mid, that means we are in a sorted section, right? If it is not, we need to move to the next section. If it is sorted section, we need to check whether the target exists in this part of the array. If it does exist, we move mid to the left. We do high is equal to mid minus 1. If else, if the required target is not in this array, we move it to the next part. So it becomes low equal to mid plus 1. The same happens if we move to the next part and check whether the target exists or not. We move to those part, we check whether the target exists in that particular section. If it does exist, we keep on manipulating the high and low accordingly. So this is the intuition of solving the problem. Now I'll be sharing the code, and I really encourage you all to do this on your own. And this is the solution. We take low and high, we check whether low is lesser than or equal to high, which we use for binary search. We take the mid and use this algorithm to avoid overflow, and we check whether the mid is equal to our target. If it is, we return the index, else we check the first condition. What is it? Let's take the example, right? Let's take this example. It's 2 3 4 and 5. 2 3 4 5 1 and 0. So here this part is sorted, right? This part is sorted, right? This part is sorted and this part is sorted. What will this check? What will this check? If mid is 3, I'm first going to check whether 0 is lesser than 3. If it is lesser, then I will be executing this block of code. If it is not, then I will be moving to this block of code. That means this section, the other section, right? Makes sense, right? So let's assume it went into the first block. Now what do we need to check? The target is 4, right? So we need to check whether the target exists in between this part, right? So that's what this condition checks. The target does exist in between this block. That means we need to move the mid to the left, right? So the high becomes mid minus 1. So that's what we have done here. If it does not exist between this, then we need to check the next part. So that's what it does. So the same goes for the next block. If you are happening to check here, we check first whether the target exists in between this. If it does, we move the low equal to mid plus 1, else we do high equal to mid minus 1. Then when we find our target, we return the index. If you are not able to find our target, then we return -1. So this will make sure that we will be solving the problem in O of log n time complexity, and since we are not using any extra space, the space complexity will be O of 1. And that's it for the video. I hope you guys understood the video, and if you did, please give this video a thumbs up and subscribe to this YouTube channel. Bye bye guys.